Welcome everyone. Hope your day is going well. It's late afternoon here in Portland, Oregon. And I'm going to see if the audio works. Welcome everyone. Yep, it does. Okay. So today's audio is brought to you by this little wireless lav mic that I've got that I really love. So it's a DJI. It's got a magnetic thing on there. Just clip it on. I like to use this as it's not as sometimes I use this, which is a Shure mic. But I like this for the flexibility, and it sounds just as good as the other mic, I think. But I like to go back and forth. The only problem with this mic, though, is if I go to the bathroom and I forget that I have it on, then that could be embarrassing. So today I'm working on OISM, which is Optimized Inter-Subnet Multicast for EVPN VXLAN. Specifically, I'm working with Arista EOS because I'm familiar with that, and it's the one I'm most current on. And their implementation of containerized EOS is very lightweight. So I'll show you what I'm building here. So this is some courseware that I'm making. And I guess I can. So I wanted to play around a lot with. I'll just start up from scratch here. So I'm so spine one. I got two spines here, which is important for like the multicast, just to see how the paths work with multicast. And then I've got 6 leaves. Again, that's another reason why I love containerized EOS. Is they're only about 1 gig a piece in terms of how much memory they take up, and they can run on one virtual CPU without any problem. So they work out really well for this kind of lab environment. And let's see, arrange, we'll distribute that way. So that looks good. Maybe a little bit wider. And then under each of these, I have a 1 or 2 hosts. So this is host 1. I'll make it a different color. I typically use green for hosts. I don't know why. That's just, maybe it reminds me of VMware. So that one's host 1B. Host 2. So I mostly just have 1 host per device, per leaf. And that's because I'm part of the thing with OISM in the way that it handles multicast is to handle the situation where we have, multicast was built for 1 M router, but in EVPN VXLAN, because we're doing distributed gateways, that 1 M router is now 5 or 6 in this case, M routers. 2, 3, 4, 5, 6. So how do we handle things like IGMP joins, and how do we do, we'll get into more fancy stuff like doing things like EVPN all active or MLAG. But right now I'm just doing the basics. And honestly, I am not current on my multicast. So I've just been playing around with it for the past day or so. And I've never, up until recently, I've never labbed OISM. So I didn't even know if containerized EOS could do it until recently. There was someone from Arista that participates in the Arista Reddit that pointed me to It's a JTAC dude. He pointed me to a GitHub repo that had a working config in CUS. So I played around with it, and I was able to get it to work in my environment and figure out, you know, what the necessary bits were. So I was able to get this up and running, and now I'm doing a more conducive, you know, everyone's got their own way of doing a lab environment. So this is the way I wanted to do this, to explore things like how does multicast behave on a lot of different leafs with a lot of different hosts, some on the same VLAN, some on not. So for example, these hosts, I'm going to put them on VLAN 10 or whatever the VNI is. Almost always when I'm talking about VXLAN, this is kind of an interesting thing. When I'm talking about VXLAN, I almost always use the term VLAN because that's what we're doing. We're stretching a VLAN. But VLANs in VXLAN are not globally significant, but we almost always treat them like they are. So we don't have multiple different VLAN 10s. I did a video recently, live stream recently, where I configured VLAN translation, where you could have overlapping VLAN IDs depending on the tenant. So VLAN 10 would be one VLAN for Coke, and VLAN 10 would be a different VLAN for Pepsi. But we almost never do that. So I just take the shortcut and say it's VLAN 10. So this will be VLAN 10. This will be VLAN 20. Just simple network. We're going to do all IPv4. So so traditionally I have been doing, or not traditionally, recently, all of my EVP and VXLAN underlays have been IPv6. So even the loopbacks. So I don't even need to do RFC 8950 or 5549, where you can do an IPv4 with an IPv6 next hop, or IPv4 network with an IPv6 next hop. Just because I thought, you know, there's not really any reason to do IPv4 in the underlay anymore. I mean, there wasn't really, but in terms of how many addresses you have to work with, it's very beneficial to use IPv6. I think in the long run, it simplifies things, and it's not that hard to get used to. But because I'm starting with, I'm still not quite as familiar with multicast in OISM, there's probably stuff I'm going to learn here. So I want to use IPv4 just to keep everything, get comfortable in my chair. Oh, I need to grab my coffee so I can talk while I'm getting my coffee. I drink what I call gas station coffee. It's a vanilla coffee because when I'm on a skydiving trip, I often stay in rural areas and I go for my coffee rather than the bad motel coffee. I'll stop at a gas station, get coffee, and then they've got vanilla coffee. So I started drinking that instead of fancy coffee. So this is like, this is Dunkin's vanilla coffee. It's a little late in the day for coffee, but I actually don't get wired by coffee. All right, so this is the environment that I built. So I built it out, and it's already up and running in Container Lab. So this is what that looks like. And then let's clean this up here. And I think everything's about ready. Yeah, so they've got an EVP and VXLAN configuration on them, but there's nothing. Oh, I was playing around with like path selection and link state. Couldn't get that to work, but I'm gonna go ahead and do a new deploy. What is with my prompt here? It's I'm just overwriting whatever's on the devices right now. So if I go to leaf 1, so I've already got a basic EVPN VXLAN config going. What else do I need to do? I don't think I've configured the host ports. Yeah, I have not. So I'll go Internet E4, switch port, access VLAN 10. Then I'll go to leaf 2. Okay. I'm gonna leave 4. All right. So that looks good there. I'm going to go into host 1. It does have an IP address on it, and I can ping, and that looks good. And go to host 1B. Okay. What was I going to do that one? 13, 14. Switch port. I can ping my gateway. Cool. So if I'm on leaf 1, if I do show MAC address table, VLAN 10. Oh, yeah, that's something else I wanted to do. I do see their MAC addresses, but if you are doing labbing, I highly recommend, if you can, most platforms do support something like this, is changing your MAC addresses. So on host 1, internet E3, or interface E1 rather, that's the connected to the leaf, MAC address router, I change it to 1. So now when I ping my gateway, and I do a show MAC address table, now I've got that in there. So it's going to be immediately easy for me to recognize what device I'm looking at, versus this is the old host 1 and this is host 1B, and it's going to be hard to keep track of the MAC addresses. So just setting them to something you recognize. So the command is MAC address router, and then you give it. Do that. Sometimes it'll take a second to ARP. It's one of those things with virtual platforms, is sometimes it doesn't behave exactly like you would think it would. There we go. Or sometimes the reactions are delayed. So now I've got 1B, and I've got 1, and I got 1B. Cool. And then I'll go into host 2. MAC address table. I'm sorry, MAC address router. One 10.1. Again, takes a second for it to ARP. Oh, it actually might not have that leaf configured. No, it is. Don't see it in the MAC table. There it is. And there it is too. That's good. And then I'll go to leaf 4. So I would call this mise en place, things in their place. All right, so I should be able to go into host 4. I'm skipping host 3 because it's the same as host. Host 4 is the first one on a different VLAN. (2014). Oh yeah, I'll need to do an IP route here. Write that. Make sure my hosts have the same. It does. This one does not. Save the config. This one does. Okay. Now I should be able to ping my gateway, but I can. And then if I look in the other devices, I'll just check to make sure, show BGP, EVPN route type MAC IP, make sure I see all the, so EVPN VXLAN is working. It is distributing the packets. However, I don't see, oh yeah, that's right. I did not change. So host 4 MAC address router. So it might take a second to ARP. Repeat 200 interval 3. There we go. So now we should see 4. There it is, right there. So MAC and MAC IP. Let's see here. Should see 4. All right, so we're going to do a couple of commands here. So start playing with OISM. I got these from Paul Lavelle, and they work really well. So thank you, Paul, for posting that on GitHub. So host 1 is going to be the server. So we're going to go to bash, sudo bash, and then we're going to use iperf. So we're going to have it subscribe to a multicast group. Let's do 1239001. -I1, okay. So a couple of things about this. We're not using the 224000 network because we want, because that one, if anything in that multicast range, that /24 is going to get broadcast everywhere no matter what. We're going to watch the default behavior of multicast in EVPN VXLAN without doing anything to enable it. It's going to flood it into the local subnet because we haven't given it any rules. And we're using port 51,000 because we want to use something above 1024 so we don't run into the packet filter on the control plane, because it uses what's the command? IP filter, a filter, what is it? What's the command? IP tables -L for list. So there's some rules in here for the Linux IP filter. So these are all implemented. Yeah. So what we want to do is we want to allow, it looks like this is a range of ports that we can use. So we want to make sure that we're using in that range for testing. So 51,000. So what I've done is I just told my local gateway I would like to subscribe to 239.0.0.1. So this should be an IGMP join. Show IP IGMP groups for VRF. Yeah, so it doesn't see anything because I don't think we haven't really configured anything, so I don't think it's going to do anything. But an IGMP join was done. So it is a server, and that'll set up a client. And I'm going to do the client on the same switch. So we're not even doing anything over EVPN. Let's see if I can actually see the IGMP join. I don't know if I can. What is this? What kind of traffic is this? Well, that's all the SSH traffic. All right, so yeah, so this is the Ethernet 1. And see if we saw it. We're seeing some. Okay, yeah, we saw. So this is Multicast. Yeah, it was an IGMP. So we saw that. Okay. I'm going to do on host 2. I'm going to do a command. So iperf client 239.0.0.1. Is that what I used? Yeah. 239.0.0.1. And then specify my address. So we're using the same port. So what this one did, I got it mixed up. So I just subscribed. Hey, if there is I want to find out any data that's sent to 239.0.0.1. So I'm about to send some data to 239.0.0.1, and we'll see if we see it. Yeah, we do. So I'm getting packets. The subscriber's getting packets. And the other thing is this is a non-subscriber, and I'm getting a ton of packets. So we're getting this. It's being flooded throughout the bridge domain, flooded throughout, not only locally on the switch, but it's also being flooded to the other VTEPs. So this is just EVP and VXLAN on a single bridge domain, or VLAN, same thing in this case. And it's flooding throughout the entire domain. Let's see if we can do anything in layer 3. I don't think it's going to work. So let's do the same. Let's see if I can do a subscribe. So subscribe there. And then on host 4, well, make sure I can ping my gateway. Make sure I can ping the other hosts. 10 or 11 rather. Yep, I can ping. So inter-subnet routing is working correctly. Okay, I just did a subscribe. And I'm going to send a bunch of data. Okay, so it's not getting anything on the other subnet. But it is still being flooded inside of the VLAN. Okay, so we've got some baseline here. So let's see if we can be a little bit more smart about how we do, see if we can do IGMP snooping so that this host right now is not getting any of the stuff on that subnet, because it shouldn't. I mean, there's no reason to, because it's not subscribed, but it's still getting flooded throughout. For every port on that VLAN, it's getting flooded out. So let's see if we can figure that out. My template. So I've got a templating system built, but I did not put in anything for the interfaces. So let's do some templating. Actually, you know what? Never mind. I'm not going to do that. That's going to take some time. And I want this to be about OISM. All right. So OISM. So on the leaf. Oh, I did turn on IGMP sparse mode. So I did that. What if I did IP IGMP? I need to do that on... Oh, yeah, that's fine there. All right, so see if that would do the trick. So subscribed. And then sending the data. So did we get it? Yep, we're getting the traffic. Yep, that worked. So cool. So inside the VLAN, we have distributed IGMP snooping, which is really cool. So how do we do that? I think it's through the show BGP EVPN. Yeah, so we've done source group. Oh, did I already configure? Yeah, I think I already did configure. Should run interface VXLAN 1. Yeah, so 239001. That is interesting. How did that work? So IGMP snooping seems to have worked. Oh, because it's getting to the switch. Okay, so we didn't need to distribute that. So it's working locally. I'm just trying to figure out how all these mechanisms are working. So if I go into leaf 4, I do show, I'll go leaf 1, do show IP, IGMP, VRF, groups. All right, so there we go. Okay. All right, what else can we do? What's confusing me is it's ** for the source in the group. So that's an SPMSI route. What does that one do? All right. Let's see what else. So I didn't get anything on the other subnet. So I'm subscribing to 239.0.0.1 and haven't gotten anything on the other subnet. So let's see if I can if I can fix that. And I'll do EVPN multicast. I really should be automating this. Okay, so subscribe. No, it doesn't work at all. What are these? Okay, SMET route. So that's good. That's what we're looking for. Maybe I need to do this again so it does a join. So I'm sending the traffic, but it's not going anywhere. Oh, do we show PIM neighbors? No, got that going. It also had the example that I saw also had a loopback interface. I think it's on there. Yeah, it does, but I don't think I have it set on the VLAN interfaces. Nope, it is. Nope, it is there too. So that's not the problem. So one problem I'm seeing is I'm not seeing show BGP EVPN route type is join sync. So this should do a join. So that should have generated a type, what, 6 route? Type 7. Do I need redistribute IGMP? Nope. Maybe we need to refresh it. Subscribe. How'd this work in the other day? Sending to it. I'm host 2. Those are the EVPN routes. So got SPM SI and SMET and IMET, but I'm not getting the IGMP stuff. So what should happen is when a host on a switch does an IGMP join, it should create a type 6 route. Is that what it was? Type 6? Type 7. Yeah, type 7 route. So that everyone else knows who did a join for that. So what the heck? You know what? I'm gonna have to, because I'm changing so many devices and changing so many parameters. I'm gonna have to do this entirely from the template now, because otherwise I'm gonna miss something. This is another reason why automation is so good. And how am I gonna do this? It's the configuration on the interfaces. So devices, do I have one that already says device? No, I do have, yeah. So endpoints. I'll do this on a switch by switch basis. So leaf 1, Ethernet 1, Ethernet 3. Let's do something really rudimentary. So what I'm doing is just a quick data model so I can configure the host interfaces, because that currently it's not in the template, but it needs to be. So I need to put this into, so it loads it up. And 10. That should be 20. So by doing this, and then I put it into the template, right here. So I'm going to do a loop for Ethernet in connect inventory host name. Endpoints. So this will have it loop through these. Then I do another loop. And points. And endpoints. And inventory host name. Okay, there we go. Interface Ethernet. Switch port mode. Or switch port access. VLAN. All right, let's see if that works. And then get rid of that. Oh, I didn't end the loop. Key. Let's see what we got. Oh yeah, so there we go. And then I have to do a an if statement if leaf. And tab that so I can see it, and if. See if that did it. Yep, it did. All right, so I can do this deploy now. Gonna reset everything. Didn't like my access command. Switch port access. There we go. Subscribe. All right, now it's working. Subscribe. All right, so that's where it's working again, at least on the local subnet. Let's see if we can get the VRF. All right, so we'll build and deploy. So EVPN Multicast, turn everything off. Subscribed. Send. 2239, make sure I got the right. 239 5100. 239001. 239001. Okay, so now it's not working. See if it works on the same switch. I would assume yes. Yeah, it does. It's just not making it across the layer 3 boundary. And all because I turned on EVPN Multicast. So what am I missing? I'm IPv4 Multicast on. Oh, I didn't do IP IGMP for the interface VLAN. So let's see if that did anything. Oh, that did do something. Oh, that's on the same switch. Subscribe. Send. Okay, nothing. Same switch that works, different switch. Doesn't work. What if I did 224? 224-200. It'll just tell me flooding it in general has worked. Okay, that did. All right, so it's an IGMP problem. Because when I do 224, I mean, just doesn't matter about IGMP at all. It just means flooded into the network, and it is making it is getting flooded. So that's how we work these little mysteries. I'm gonna be right back when I use the restroom. Coffee's gone through me. Be right back. I think so. One of the frustrating things with Arista is the documentation is not very good in a lot of places, or it's lacking in some places. What documentation they do have is usually pretty good, although sometimes outdated. Like their QoS documentation tells you what to do for the Trident 2 chipset, but doesn't say anything about 3 or 4. But this part in particular, there's not a lot out there. And then they have these TOIs, transfer of information, but you have to have an active support contract in order to get access to that. And I do not. Even when I was teaching for Arista, I didn't have access to it, which was weird. But now I definitely don't have access to it. So kind of have to play around with this. And there's not enough material for like ChatGPT to give you a config that'll work. There's not enough public out there. Okay, so got IP IGMP. What the heck else do I need? It's because I don't have a rendezvous point. I don't see one in this example config. Oh, maybe. Excuse me. No, it looks like we have those in there. All right, host 1, 239. I was using the same address, so let's do 99. It's supposed to not care, but so on the same switch it's working. On different switches, it's still not working. 239.0.0.99. Two three nine zero zero 99. I had this working the other day, but I wasn't quite sure what was going on. Yeah, maybe I'm missing multicast or rendezvous points. Can't remember if I need them. All right, so what do we do in the... Yeah, so let's do... it may not be routers. I think that might be what I'm missing. So I'll do this. I'll make leaf 1, spine 1. That's my loopback 0. For spine 1. This will be my rendezvous point because it's already in the routing table. Not RIP, RP. All right, build and deploy. Well, that seemed to work. Where did that come from? Okay, that always worked. Nope, doesn't work. Should be a join sync. Oh, you know what I should do is just everywhere. Try redistribute IGMP. That's what I'm feeling right now. So we're redistributing IGMP. We've got rendezvous points. Do I need to do a multicast group for every VLAN? So let me try doing a multicast. Let me put in interface VXLAN. Multicast group. would be VXLAN. Oops. So this would be the same. Mulicast. Okay. Build. So looking for interface VXLAN. Put that in a multicast script. Good. Do that again. Build. Okay, and then we'll do deploy. Nope. Multicast group. What in the heck? Another thing I could do is Put in a new flood. So I think that's what I was doing yesterday or the day before, whenever I was doing this. So we have a flood group and a multicast group. Let's see if that will deploy. Yep. $239.99. Yeah, I'm just not getting it to. What does $99.99 have to do with this? I could have sworn I had this working. All right, taking out I had that, and then I'm taking it out on taking that out too. They did have that there. Huh, there we go. Well, no, that's... Is that on the same switch? Yeah, I think that's on the same switch. Yeah, I don't care about that. 239.0.0.99. 239.0.0.99. So it works on the same switch, doesn't work on other switches. Shezbot.
A is for Apple. A always stands for Apple. There's nothing we can do about that.
I'm gonna throw a Hail Mary here. Just gonna start it back up. I'm power cycling it in case there's something weird that got stuck in the something. I don't think this is gonna fix it, but as far as I can tell, I've got the configs right. I did have it working before, at least I think I did. Okay. All right, done with my gas station coffee. That was the last that I had in the thing. I'm gonna get myself some spicy water. All right. All right, config is still there. Let's redo all this stuff. Host 1. Host 3 didn't save its config. Okay. Ugh. I mean, I got it on video. It wasn't working, and now it is. So I still don't know what exactly I needed to make all this work. Like, did I need a rendezvous point? I think I did, but it wasn't in the examples. Oh, that's frustrating. So I do want to try. So what I'm going to do now is to see if, okay, so it is, IGMP is working outside of the switch, and then let's do, let's get out of host 1B, which is connected to leaf 1. And then let's do bash, sudo bash, tcp dump, -I, Ethernet 1. Okay, so it is not getting flooded except for people that are subscribing. So let's see if I can subscribe. Looks good. All right, now the real test. See if it goes across the network. See if we can route it. Okay. Cool. And we got and then we can see the routes. No, don't see any of those. Is that because I had, huh? Because they're attached directly. No, they should still see the. Oh, did I go on the right 10, 1, 20? didn't specify the right IP address. 2014. It worked anyway. All right, I'm not seeing any IGMP joins. There should be another route type in here, and there's not. So crap. Why the hell not? So I'm drinking my Kroger spicy water. It's my favorite flavor. So it's behaving the way that I think it's supposed to. Kind of. Maybe I need to do that. They should be signaling to each other about the IGMP joins through BGP, but they're not. I don't know why. My understanding is that's what needs to happen. So one note is that the behavior, sometimes something gets locked up and it wasn't forwarding or doing anything, and I had to basically restart all the devices, and then it worked. Let's see what version I'm on to. 4350F. 1F is out. I don't know if that's worth upgrading to. Can I tell? Sudo docker image ls. And I don't have anything more recent. Let's see if I do. Nope. Try to log in. See if there's a more recent version. Not that that's going to fix it, but the multicast stuff I'm guessing is on the trickier side just because it's not. Oh, 2F is out, so let's grab that. So I typically grab, I don't grab the 64-bit version. For containerized EOS, I don't think there's any reason to. Because it just, how much memory it can handle. That's the big thing with containerized EOS. Or a 64-bit version. And it don't really matter that much. You can just drag and drop files. Let's drag it into here. It's not very fast though. It's 34 megabytes per second. I've got a 5 gig link. It'll take a second. All right, so I'm going to shut all this down. And boot it with a new version. Again, I don't think it will fix anything, but it's always a good idea for these kind of features. That I don't know when they started supporting multicast in containerized EOS. But I'm guessing it's pretty recent. So might as well boot it into the news version. Some stuff has been working for ages. Like Unicast EVPN is fine. It's been working for like since the 20s. Give this a chance to get booted. Again, it's just figuring out what parts are needed. So I'm trying to build a checklist. After this, I'm going to go for a run. Okay. There we go. Lots of, okay, subscription going on for 110. The flood group. Two, 39111. All right, traffic is flowing. No join syncs. Okay, let's try, make sure the version's right. Yeah, we're on 2F. So now I'm going to take out the flood group. And let's see if that does anything. So build configs, deploy configs. This is the really nice thing about automation is once you've got the template going, which can take a little bit, then making a change to like 6 devices is really easy. I just did something there real quick. So the flood groups are gone. Because maybe that's what it needs. I don't know. And they are deployed. Show IPM route. Okay. All right. Yep, so it looks good. What the heck? Let's try something here. I'm going to do 224. It should be just be the local network. So I should not see it on the other side. Okay. I was just checking to see if like the multicast packets were being bled in. 239.99. Oh. 1.1.1. Yeah. All right, let's see what's in one of these SPMSI. Tunnel ID. But I don't understand also what's star star. Let's try this. Hmm. All right, I'm going to give it up for tonight. Can't quite figure out what in the herc is going on. All right. It's not behaving the way it's working, but it's not behaving the way that I thought it should or the way that I understood it. So either my understanding is wrong or the behavior is wrong. And given this is containerized EOS, it could be one or the other, it could be both. But one of the two has to be true. So my understanding is wrong or the behavior is wrong. Or the config is wrong. So behavior, config, understanding. And that's really what it is about when these type of environments. It's behavior, config, and understanding. So I'm going to sit on this for a little while. I'm going to go for a run, and then I'll take it up tomorrow.